So this is not going to be difficult. So let's say, so this is the R circuit again. So the last R circuit that we solved, in that we had a finite resistance attached at one of the end. And we have a transverse magnetic field which is uniform and constant. And the rails having resistance per unit length equals to lambda ohm per, let's say, ohm per meter. And we have a slider, and this slider begins at this position, almost close to the left end. And this is given a velocity v naught at t equals to 0. So after time t, this is somewhere here. And the velocity is v. And what we assume that, okay, let's say it has traveled a distance x. So the first thing is, what is the induced EMF at that instant? So we know that for a moving rod in a transverse magnetic field, the induced EMF will be VBL, right? So this is the formula that you should remember. So let me add on BL. BL. Now the question is, what is the I induced? So for that we need the E induced upon the resistance of the loop, this entire resistance. So the entire resistance will be how much? So it is R plus twice of lambda times x, because we have lambda x above and lambda x below. And the rod is purely connecting. So pure conductor means there is no resistance for this rod. So now you can see the current itself is a function of x, and that is the whole idea we are doing this. So this will act as a cell of a polarity like this. This is induced. And we know that whenever there is a current carrying wire in a field, the wire will experience the magnetic force, right? And the magnetic force will be as per the current direction. So we can see the current direction will be upward. This is the direction of I induced. And if you write ILB, L cross B, L upward and B inside, so L cross B will give you left force. So we know that the force will oppose the motion, and that is what we have discussed many a times. So the force which is ILB will oppose it, but the velocity at that instant is forward, and therefore it will create retardation. So we can say the acceleration equals to minus ILB upon mass of the rod. And why minus n? Because the velocity and the acceleration values are opposite, so it is actually retardation. So when we write acceleration, we put minus n. So A turns out to be how much? Minus BL by M, and the I induces so we can add as BL so A turns out to be minus B square. So it is interesting to know that the acceleration is function of V as well as X. It is function of both. So the differential equation that we must use here is A equals to V d by dx. Correct? Because we need V and X both. And this we can add as minus B square L square V upon. So you can see the in the next step we can cancel the V. And now this is quite integrable because it's a function of only X. You can do the integration. So when X was 0, the velocity was V naught. So when X is X, you can write velocity as V. So this is what you are supposed to find. Find the velocity as a function of X. So V minus V naught turns out to be minus B square L square. And this will be ln R plus 2 lambda X by R upon 2 lambda. So this will become so an integration we divide with the coefficient of X. So the final answer will be V equals to V naught minus B square L square by 2 lambda M. I think that is 2 lambda M into ln R plus 2 lambda X. So, okay, they will not ask you other questions because this is only doable mathematically. Other questions will become mathematically challenging. So, but the process, the modus of solving question remains same. So, every question of R circuit will have some definite question and definite answer. And the process is very simple. You always start with the E induced, then you go to I induced, then you go to laws of motion. And after the laws of motion, you write the acceleration. Then you use kinematical relation to or calculus to solve the differential equation which you obtain. So the strategy is almost constant, and no matter which question you attempt. We don't have a different strategy. We have same strategy again and again. We do the same thing. Okay. So let's go to the next question. So this is the third variety of R circuit. In this variety, what we are going to do is the R circuit. So now the rod, earlier we were giving some initial velocity. So we were imparting velocity to let the rod to move, but now we are applying a force, and we are going to assume force as constant. And at t equals to 0, we are going to assume the initial velocity of the rod as 0. The mass of the rod we will take as m and the length as l. So again, the modus operandi of solving the question, the method, the algorithm, you can say, or strategy, it is still the same. Because of the force, it will accelerate for some time, and therefore it will have some velocity. But because of velocity, it will have EMF. But because of EMF, it will have current. Because of current, it will have the opposite force, the force that you will see in the backward direction. So that force will reduce the acceleration. So a time will come when the force on the left due to the magnetic field on a current carrying wire, which we call ampere force. The ampere force on the wire, the ILB is also called ampere force. So the ampere force on the wire and the applied force on the wire will balance out each other, and then it will not accelerate and will move with constant velocity beyond that. Such velocity we call terminal velocity, because that is constant in value. So we call it terminal velocity. Understood?
So now we are considering resistance in the reels.
There is no resistance in the rim. The applied force and the ampere force, the ILB force, will balance out eventually.
Yes.
Because as long as it will accelerate, velocity will grow. But as velocity will grow, E induced will grow. As E induced will grow, I will grow. As I will grow, ILB will grow. At some point, it will balance, isn't it?
Yes.
And beyond that point, it will move with constant velocity. That constant velocity we call terminal velocity. Okay, that is called terminal velocity. And then once the terminal is attained, then the work done or the power delivered by the applied force will be exactly equal to the power dissipated by the resistor, because no part of work is getting consumed by the rod, because rod's velocity is constant, which means rod's kinetic energy is constant. And if rod's kinetic energy is constant, it means it is not getting any energy from the applied force. So the question is where that energy is going. Like if F is applying force on the rod and if it is getting displaced, so it is doing some work. And doing some work means it is giving some energy. And giving some energy means technically that should increase the velocity of the rod. That should increase the kinetic energy of the rod. But if that is constant, it means all of the energy is now getting dissipated. So that is called the steady state condition. So this circuit will attain the steady state condition, which is very typical. So okay, so what I want is that you start the first step and keep on writing. So you know the algorithm, right? E I A B D
So
A.
here I will be just E induced by R.
Yeah, here it's only in this way. Correct. And then solve. Then solve the differential equation. Yes.
Sir, I'm getting terminal velocity as FR by B square L square.
Yeah, I think that's correct.
Sir, and I also got velocity in terms of T by solving the differential equation.
Yeah. So just to repeat the process, the first step is at any instant. So let's say at some instant it is here.
Yes, sir.
So you will assume at some instant t the velocity is v, and therefore the E induced will be how much? And then the I induced will be how much? So far, so good. The only thing is when you write the ABD, then ABD will have two parts. One is the applied force, and other is the ampere force, which you can write as I. So for laws of motion, for laws of motion, point of view, what you can write is F minus ILB is equals to mass into acceleration. Okay. And I again comes out to how much? BLV. So F minus B square L square by R into V is mass into acceleration, which you can afford solve. So you can write A equals to F by M minus B square L square by MR into V. Okay. And then to make it easier, you can write as alpha minus beta, where alpha is F by M and beta is B square by. So to find the terminal velocity, which is what is at terminal velocity, the acceleration becomes zero because you will move with constant velocity. So at terminal velocity, we can say since V becomes constant, which we call V terminal, A becomes zero, and the moment you put A zero, we'll get the answer. Let's call one. One implies so the V terminal is alpha by beta, and what you said and what you got was correct answer. So answer was alpha by beta. Is
Yes,
FR by.
FR by B square.
And to solve in general, to find the T function, you have to solve the differential equation.
Yes, sir.
So you can say dE by dt equals to alpha minus beta v, and you can add as. So when the T is zero, this is 0, and T this is V.
Yes, sir. Sir,
Yeah, so now we can solve. So ln so alpha minus beta v upon alpha is e power minus beta t. So the v turns out to be alpha by beta into 1 minus And this is very famous answer. Alpha by beta into 1 minus. So the coefficient of the velocity is called the drag coefficient, and it will decay. It will create a decay. Okay. And the constant term, you can understand, the constant term will give you the constant answer, right?
Yes, sir.
Yeah. So we have a linear term, a constant term, and then a decay term. So e power minus beta t is a decay value.
Yes, sir.
I hope this is what you got, right?
Yes, sir.
Now this question can come in various forms, like instead of applying a force, what if we have a vertical R circuit? So it is no longer horizontal, it is vertical.
Sir, gravity.
Yeah. And then it could be a tilted one also. So I can tilt and then I can make a circuit. So you can understand the only thing which will change
Is the FPD.
is the ABD or the force, right? So
Yes, sir.
you may introduce even a friction if you want. The end result is it will change the laws of motion equation, but the method to solve, let's say if you release from rest, and if this is R and this is having mass and L, and we have a transverse field, so generally in some question you may use the B is like a horizontal field, because if the plane is vertical then B is horizontal, and you may think B as the horizontal component of Earth's magnetic field. So sometimes you have to use BH for the horizontal component of Earth's magnetic. So sometime in some problem you will come across BH. So to find the terminal velocity, we can just write the answer. It is Fr by B square L square. So the answer will be mgr. So in a way, it's good to know the formula. Okay, directly, just not to solve it from scratch, but just write it down and we'll get the answer.
Yes, sir.
Okay. So this is the one variety of question that we come across in which we have R. There are other varieties which you can solve, and you have to solve from Irodov actually. So after R circuit, we will move towards something called C circuit. So we will have a capacitor. So the C circuit, we will start with something called electromagnetic gun. Just a moment. I need to write down the paragraph. First of all, let me do a circuit. No, no. I'm just writing. So what we have here is a capacitor with some initial charge. Okay. So we have a capacitor with some initial charge, and there is a rod of mass m length L at rest. It's not required. The moment you switch, I mean, let's say the charge here is Q. So the moment you switch on, current will flow because the capacitor will create the current, and because the current will flow, so the rod will accelerate actually. But as the rod will accelerate, it will have velocity, and as it will have velocity, it will act as a cell, and as it will act as cell, it will oppose the incoming current. So a time will come when the potential across the capacitor and the potential across the rod will become equal, and therefore no extra current will flow in the circuit. In a way, again the rod will attain the terminal velocity. Okay. So there are three questions that you need to answer. First, find the questions clear. Find final charge of the capacitor after closing the switch. Second, the maximum speed attained by the rod. And third, the value of m, that is mass of the rod, for maximum efficiency. For maximum efficiency of the gun. So in a way, you're shooting the rod once you close the switch. So think about it. Uh, Try writing a question and how you're going to approach. I'll take a short break and I'll come back. Okay. Questions
The
clear?
gun part, I don't exactly understand.
The gun means the slider will act as a bullet.
So as in like we are giving an initial velocity to it?
No, because you're giving current to it. No? So it will experience,
Okay.
because a capacitor will discharge very fast. So the current it will create is infinitely large, which is like impulsive current. And that impulsive current will create the impulsive force on the rod. ILB, I is, imagine in a formula, ILB, if I is very large, what will happen? So it is like impact force. You suddenly get a large force, and a sudden large force will accelerate it with a very high value of acceleration. So in almost no time, you will gain some, I mean, finite velocity. Understood?
Yes.
So capacitor will discharge so fast that it will get a shot of current, a burst of current, and the current will be tremendously high. You know that for pure conductor, the battery, I mean, the capacitor will discharge very fast, right?
Yeah.
So the current will be impulsive or infinitely large. Do you realize this?
Yeah.
So rod will be almost there, but it will accelerate so fast that it will gain some velocity, and that velocity will be final. I mean, it will just get velocity at that instant and will keep on moving forever. So think about it. Now, questions clear?
Yes.
So think about it, and then I'll come back in 10 minutes. Okay. So okay, I have also sent you the exact question which you can read now. Uh, there is a typo error. The theta naught is basically q naught in the options. Okay. Am I audible to you?
Uh, yes, ma'am. Sir, able to hear me?
Yes, I can hear.
So what is theta naught?
That is q naught actually. Just type. Okay, so you got the idea.
Sir, not exactly.
Okay, so first step is when you have a circuit with capacitor, you won't get current, right? So what we'll get is
Yes.
imagine again the process I mentioned. So let me just read those quickly. Give me 1 minute. So definitely when you switch on, when you make the connection, the current must have flown and therefore the rod must have some velocity by now. So the method of solving is very simple. You will again assume some velocity v at some time t, which is very small, but let's just assume v. And because some charge has flown already, so the instantaneous charge we can call q. So you begin with q naught, but now you have only q left, and I'm assuming q is less than q naught. Okay. Now the first step is writing the circuit relation. So this, I mean, this rod will act as a cell of EMF, which we know E is how much? DLV, right?
Yes.
So in this loop, if you want to read to the loop, it is like a capacitor and a cell connected in parallel kind of thing. And we know this is Q. So what will be the relationship between these two? And also remember that in the beginning, the charge is creating a current this way. So it is not the battery which will decide, it is the capacitor, because predominantly capacitor is having high voltage in the beginning. So current will flow like this. And because current will flow like this, the ampere force, the ILB, will act towards right. It will accelerate in the beginning. So anyway, before that, what is the relationship between the charge and the capacitance and the E? So you can write KVL if you want it. Or you can just write the answer. So you want to write KVL? Hmm? So minus E induced plus Q by C equals to 0.
Yes.
So we know already this is charge is C times E. That's it. E is a constant, now it's a variable. Why? Because it is E induced. So this becomes BL. Now this is the equation that you have to begin with. Q is CBLV, BLCV, whatever. But the next step is going to be current. So luckily, because you know the charge value, you can find the current, right? So it will be dq by dt, because here we don't have resistance, right? So if you differentiate a B L C being constant will come out, and V will differentiate dV by dt. So dV by dt itself is called acceleration, right?
Yes,
dV
the
by dt is
answer
called,
is zero only.
pardon?
Sir, if current becomes, oh, that's sir.
Yeah. So it is not zero, it is changing in the beginning. Okay.
Okay.
So this is actually equals to BLC. And if you write the laws of motion, So the laws of motion part will be because now the rod is in a way accelerating. It is not retarding. So in all the previous cases, we saw retardation. Now the ILB is acting this way, and it is going to accelerate because it is in the direction of velocity. So we can write as ILB equals to mass into acceleration. So this is the equation, and you can write this as uh, BL, and I we can write as dq by dt, and A we can write as dv by dt. And now this is easy to solve because the dt gets cancelled. And now because we are looking for charge relation, so we got when charge was q, not velocity was nothing new. So when charge is q, velocity is SL. Simple. So this is the takeaway question. This is the equation which is difficult to think. So BL u minus q naught will be equals to mv, and in a way we are done. Why? Because we know that q we can replace by BLCV, right, at any instant. So if you want to find the charge, you can substitute V. So whatever you want to find, you can find from here. So uh, let me find velocity.
Sorry, can you just come back in a minute?
Yeah, sure. So we put to minus sign here.
Sir, are you there? Okay.
Am I audible to you?
Sir, yes.
Yeah. So, okay, I we have to write as minus liquidity. So the minus will come here because charge on the capacitor plate is depleting. And because it is
Yes.
depleting,
Sir, I'm not able to hear you.
yeah. So once you get the V, you can substitute the V in the formula to get the charge value, right? So the Q equals to how much? BL CV, which is B square L square C Q naught. Okay. So this was the electromagnetic gun. So the last part is we got the charge, we got the V. The last part is what? Find the value of M for which the maximum efficiency of the gun is obtained. Okay, what is the meaning of maximum efficiency? So first of all, we'll talk about efficiency. What is efficiency? So efficiency is you had a capacitor which gave energy to the conductor, the slider, but not all energy because some charge was left on the capacitor, which means some energy was still stored in the capacitor. So efficiency is that how much energy of capacitor we utilized in accelerating the rod. So it is defined as the kinetic energy gained upon total initial energy stored in capacitor. What does it mean? That what amount of energy stored we were able to convert into the kinetic energy. That is called efficiency. So the answer will be half mv square upon the total energy stored, which is unit square by 2. So the eta turns out to be c by q naught square into m into v square. But a v itself is bl. So efficiency is a function of m, right? So we have m there and m here. So for what value of m, the question for what value of m, the efficiency will be maximum. So this is like a function which you have to differentiate, and upon differentiation we'll get the answer. So can you differentiate and tell me the answer? It's pretty easy. You can try this out. So tell me the maximum efficiency. So find the m for which this is maximum. So the d eta by dm must be 0, right? You can write like this. So for maximum efficiency, d eta by, so do the differentiation and get the answer.
I'm getting m is equal to 2 minus b square plus.
Once again, so you're getting
2 minus
root 2. So you have to find the m for which this is going to happen. So I think this is
for
so
b square is plus.
it is b square L square c, right?
Yes.
What's this option here? Okay, so answer is in terms of maximum efficiency. So have you made some mistake here? Or will be constant will be out. It is m by m plus b square L square c square whole square. So denominator into numerator, which is 1 minus m into this, which is because of this. Oh, okay, okay. Just, I think the definition I have to change. How much energy capital lost and how much energy? What is the efficiency? Have you defined efficiency? I'm reading the question. Have they defined efficiency? How they want to define? I think they haven't mentioned the maximum M, so they have asking the what is the okay? What is the eta max? Let's find the eta max. So answer will be eta max is C by Q naught into M. Okay. So we can replace this by M, no? We can replace this by M. So let's replace that by M. So at M, and what we have here, BLQ naught. So BLQ naught upon, and this is equal to M, so we can add 2M. So add 2M whole square. So this become CMB square L square Q naught square by 4. So we are getting C by 4 B square, and M become further replaceable because the answer is not in terms of M. So oh, that was whole square. My bad. So B square is equal to Q naught square. And QC by Q naught okay, okay. Answer what we getting is Q naught by okay, fine. So how to replace Q naught? Do we have any relation in Q naught? This is wrong. Something is wrong. We are not writing in the correct way. Efficiency will come as yeah, something like this. Option is given. Na? This is the B option given. This is the answer given.
Yes, sir.
I thought it's
Sir,
not
I
given.
got you there. So when you had checked, it was the wrong option.
Yeah, I was checking the wrong. Yes. This is the answer.
Yes.
Okay, fine. So now the next part of the C circuit is, so we'll see C circuit. Now in the first case, we gave some charge to the capacitor, and we got something really interesting. That will capacitor. I drew the resistor. Okay, so now we have a capacitor which is now uncharged. Now this is the different from the previous version. So now it is acted upon by some constant force, and we have a transverse field. So the field is transverse. Force is F at t equals to 0. The initial velocity is 0. The mass is M. Length is M. So analyze the or find the velocity, acceleration, force, charge on capacitor as a function of time t. Okay. So find velocity of rod find velocity of rod and charge on capacitor as a function of time. So try for a while, then I'll solve. Okay. You got the answer?
Sir, yes, sir.
Tell me.
Sir, I'm getting Q is equal to BCFL by M plus B square L square C into T.
Very good. I think that's the correct answer. So it's the same process. You started with the at any instant you have assumed the velocity of the rod as v, right?
Yes,
So it will act as a cell, right?
yes,
Some charge will come here, and in this case, the charge will deposit in the plate. So we can end at Q equals to C times E induced, and therefore the dq by dt, because we always need current value, and here current is increasing, so we have to write a plus value. And now you can add the laws of motion part. So the applied force is like this, the ampere force is here, ILB. So the net force equals to how much? Mass into acceleration. But you can see that current itself is function of acceleration, right? So the 8 turns out to be how much? 8 by. And because acceleration is constant, so you can find the velocity as a function of time t with using kinematical equation. And so you can find the charge.
yes,
So I hope this is what you got, right?
yes.
And F. Excellent. Okay, so we are done with the C circuit. Okay. And now we have to discuss the like 3 questions. What I want is that you revise the previous lectures, be ready with it, and then next lecture we can solve more questions. Okay.
Yes.
All right. So see you in the next lecture. Practice, revise. It's not difficult chapter. Bye and take care.
Yes, sir. Thank you, sir. Good night, sir.